Okay, so welcome back to the MathMinds Project Tuesday evening missions. Today's math mission that we'll be reviewing is called Show Me the Money. If you're watching this as a recording, follow along and pause the video after after each challenge is presented to you, and of course give it a try before hitting the unpausing the video and listening to the solutions of the folks in the room as well as the math mentors and myself. So for those of you who joined in the last few minutes or so, hope you guys are doing well. We heard from some of you already. Many of you have perhaps completed your midterms already for the semester or are doing so right now. So wishing you the best on your midterms for your college classes. And hope you're ready for some mathletics today. Um, I am, and I know that the other folks on the Math Minds team are as well. So let's jump in. Oh, excuse me. Let me back up before we jump in. Just a couple of comments or housekeeping things. Did you guys take our 30-minute Math Minds Math Challenge? Right, that's a Google form, and the link to that math challenge would have been sent to you more times than not by Michelle, who actually is not on the call today. So just check back with Michelle's emails and you'll see the link to the math challenge, which we want everybody to do, especially if you're new to the Tuesday meetings. Please have a look at Michelle's emails and do our one-time math challenge. Number two, have you subscribed to the YouTube channel for Brooklyn No Brainer, where we have actually a playlist of all these recordings? If you haven't, 16 people already have, so maybe you have already. Just started this channel actually 2 weeks ago, so please do that. You can find the Brooklyn No Brainer YouTube channel by simply typing in Brooklyn No Brainer into your YouTube search bar, and you'll find it very easily. And then finally, have you shared our promo with other students, faculty, whomever, friends at Brooklyn College, or if there's anybody from Baruch or anybody in CUNY, anybody else on the call? We're inviting anybody across the CUNY platform to join us. Of course, most of our students are Brooklyn College students. We're also starting to get people from Baruch that are registering for MathMinds as well. Happy to have anybody across CUNY. So please share this graphic. I know this has been emailed to you as well, and we'll continue emailing this to you to help us promote our Tuesday night workouts at 6 o'clock through May 4th. Now, let's finally get started, right? So today's mission that we're going to talk about is called Show Me the Money, right? Some of you, I don't know, by a show of virtual hands, have you seen the movie Jerry Maguire, the Tom Cruise, Cuba Gooding movie, Jerry Maguire? Who's seen Jerry Maguire? You can raise your hand.
Great movie.
Yes, I think Illy's in Illy's top 3 or so, she said.
Absolutely. I watch it maybe 4 times a year.
Oh, wow. Okay.
I can tell you, I can do the whole thing for you now if you have time. I can just do everybody's lines.
Oh, you have the lines memorized. That's cool. Yeah. So I didn't see. I definitely don't watch it 4 times a year, but I think I've seen it a few times. It's a really good movie. Tom Cruise, Cuba Gooding, both do a great job. Don't have to go into what it's about, but the bottom line is that um, that Tom Cruise plays a sports agent who, he's focused on making money. That's his thing, right? He likes to have lots of fancy things around him, cars, et cetera, other assets. And, show me the money, by the way, that's a line that I guess Cuba Gooding says, right? In the movie, Cuba Gooding plays a famous and a professional football player, and Jerry Maguire is his agent, and he's trying to get Jerry Maguire to get him the best deal possible. So at one point he says, "Show me the money," right? So you may have seen that. If you've seen the movie, you remember the line. So the purpose of today, though, is not to train you to be to advocate for greediness. We're trying to train you to be more thoughtful and prudent in how you spend your money, right? So the purpose here is to demonstrate how math shows up in everyday purchase and investment decisions, personal investment and purchase decisions, right? So whether big or small. Your mission was to go through, we've got 6 challenges here. 5 of them are math oriented, and the 6th one required you to kind of get out on the street and talk about sort of like discuss really more than solve math. And hopefully you gave all the exercises a shot. And if you got through some, great. If you didn't, that's okay. You'll hear from somebody else. And remember, we are keeping tally as to who gives the most correct math solutions to the challenges. So Ilya is going to be we're keeping count, guys. And Ilya is going to record that today. And we're going to add that to what we have from previous math missions. So please, keep that in mind and definitely speak out, okay? With that, let's get into mission number 1, challenge number 1, okay? So challenge number 1 starts, hopefully not too complicated, right? Here's something that we see a lot. Now, it may not be tires, could be a lot of things, but for those of you who have a car, you need 4 tires on a car, right? A lot of folks who sell tires often try this promo of buy 3 tires, get 1 free. So your local tire retailer is doing a buy 3, get 1 free sale. You buy 3 and get the 4th one for free. By getting that 4th tire for free, what is the percent discount you're enjoying on the 4 tire package? Now, if you're watching the recording, well, I'm actually going to pause the video here. All right, folks, let's jump back in. So we'll start by asking for a volunteer from folks outside of the Math Mentors. Does anybody want to be first today? Who wants to break the ice?
So, hi everyone. I am Brittany. This is my first day here.
Hi, Brittany.
Hi.
Oh, didn't you just jump into the meeting just a moment ago? I think you did, bro. No?
Yes.
Well, welcome. Yeah, so we got started. Did you have a chance to work on this exercise?
Yeah, I actually have 2 examples. 2, either is 3 on 4 or it's 1 on 4 times 100.
Okay, so well, what did you, can you explain it? Explain your math, like verbalize your steps for us.
Oh, so I put, we buying 3, but there's 4 tires. So I put 3 divided by 4 times 100.
All right, so you ended up with 3. Just gonna write what you're telling me. Times 100. Okay, continue.
Yeah, and then I got 75%.
Okay.
And then I did it another way where I had 1 divided by 4 times 100.
Ah, okay. And that gives you what percent?
25%.
All right. Now, the answer is not both of these. The question is, which of these 2 numbers is the correct percent discount?
Yeah.
One of them is correct. There's this, you gave this percentage and this percentage. Which one is the percent discount? And by the way, if you're not sure, let me ask you a different question, Brittany. How much are you paying for these 3 tires? Ah, there's no price here, right? There's no price. So that's not a good question. Does the price that you pay matter here?
No.
It doesn't matter. But let's do this, Brittany. Let's imagine, just give me a nice, easy number on a price of a tire. An easy, $100, good number. So if there was no sale, like no special, how much would you pay for the 4 tires?
400.
Right. But because there's a sale, and you're getting one free, how much are you actually paying?
300.
Right. So you're saving 100, right? You're saving $100, right? You would have spent 400, but you're spending 300. So which of these two percentages do you feel is the correct percent discount, the discount that you're enjoying?
The second one.
Right. This one. Because this would be too big, right? You're
Yeah.
not getting a 75% discount.
Nope.
If it would be you pay a lot less than $300 if you were getting a 75% discount. You're getting a 25% discount, right?
Mhm.
Now, the reason I went through that with you is because I wanted to show you kind of like how you can make the problem feel real. A lot of times we start doing calculations, we get an answer, and then we don't have a feeling as to what that answer actually means. So by kind of working it through with numbers, it helps you, it brings context to the exercise. And even though there were no numbers presented here, you were correct to say that it doesn't matter actually how much what the price of the tires are. We could have put $50, $100, $1. I mean, and I don't want to take the time out now to prove it to you, but it doesn't matter. And in fact, we could have used variable X if we wanted to and used algebra to show that the answer is 25% discount. But anyway, you're spot on. So that was a nice job. We got to give Brittany 1 point. By the way, Brittany, you may have not heard that we're tracking how many correct answers people give in all our Math Mission Tuesday meetings. So you get a point for the first challenge today.
Okay, thanks.
So yeah, good job. Does that make sense to you? Everybody else? Make sense, folks? I'm assuming that's a yes. And let me share with you, I think I have some, by the way, one thing that we did differently this time versus the past is I built into our slides some words. And sorry, there's some scribble now on top of the presentation. But if you want to go ahead and read this, you can go back to the recording and read the detailed explanation that we just went through actually with Brittany. So it's the same numbers actually. And in fact, I used $100 just like Brittany suggested in the solution here. So the answer is 25%. Yeah, let's move on. Unless there's a question, if there's no question, I'm going to move on to the next exercise. And Liat, you are correct, by the way, with your chat box answer. And by the way, Liat, you can, though I think Liat may be out of the meeting, according to what I'm looking at here, but Liat's back. You can.
I'm here. I just have very bad Wi-Fi, so it keeps going in and out.
Oh, no. Okay, great. So I just wanted to tell you that if you want to chat, you're writing me direct messages, you can change your response to everyone if you want to have everybody see what you're saying. Just change your.
I wasn't sure if we were allowed to do in the chat, like the right answer to just write in the chat. Or I don't know if you said that or not. That's what I did.
Well, okay, fair point. On that respect, usually we do say like when to put things in the chat box and when not to. Okay, so you understand. You can DM something and you can write to everyone. Okay.
Right.
Let's move on.
Thank
to challenge number 2 out of 6. So challenge number 2, you're considering a family membership at Big Box. So Big Box is just a generic name, kind of like Costco, places like that, BJ's. A new large volume retailer in Brooklyn. Big Box family membership costs $150 per year. And you've done some research and found out that big box prices are on average 10% cheaper than where you normally do your grocery shopping. You normally spend about $400 per month on food items for your family. And you believe that if you join Big Box, you'd be able to do all your food shopping there. So there's a few different parts here. Part A, given the information above, does it make sense mathematically to buy the membership? Part B, what would be the break-even price for membership, at which point you would be financially indifferent between joining or not joining Big Box? And then finally, what are some other factors which could impact your decision about joining this big box retailer? So we'll pause the video again here for those who want to, just to give you guys a minute to work on it if you haven't seen it before, and then we'll unpause and give someone a chance to explain their solution. All right, I'm resuming the recording and give you guys a chance. Now, most of you hopefully worked on this already, but now you've had another minute or two to kind of formulate your answers. Does anybody want to give part A a shot? Who wants to give part A a shot? We heard from Brittany. Who wants to give part A a shot?
I can go.
Oh, hi, who's this?
This is Mila.
Oh, hi, Mila. Okay. Go ahead, we're listening.
Sure. So I figured out the non-member price, which would be the average of 400 times 12 to give us 4,800 per year. Then I figured out the membership price, which would be 400 times 0.10 subtracted from 400
Oh, so that would be the
multiplied by
same.
12.
So wouldn't that be the same as 400 times 0.9 actually? Can we just do it that way?
Oh, you're right. Okay.
Right? Yeah.
0.9.
Works
Okay.
out the same. And times 12 for 12 months.
And added the initial membership cost of 150.
Okay. Okay. Oh, plus 150. Right. Okay.
Yes.
All right. And what is that total for?
I believe it's 4470.
And okay. And this was 4,800. Right. We already have that out here. Okay. So you compared, essentially, just to reiterate what you said, you compared how much you would pay for groceries across the year, given your normal spend of 400 a year, and you multiply that by 12 and got 4,800, and you compared that to the price, the 10% discount price from Big Box, which you can do, as you said, by doing 400 400 minus 400 times 0.1, but which is the same as 400 times 0.9. So 90% of the $400 price, which is the monthly price at a 10% discount, times 12. Then you added the fee, the membership fee, and even with the fee, you got a number lower than if you didn't join at all, right? So this is lower than that. Therefore, the answer is you would join, Mila?
Yes.
Yes, and you are correct. You would join financially, it makes sense to join Big Box. Very nice. Thank you for that. Good job. Let's
Thank you.
see. Yes, and we're going to just, before Mila, I'll give someone else a chance to do part B, but if no one volunteers, we can come back to you. Does anybody want to try answering part B?
Yes, can I do part B?
Yeah, who's this? Who's this?
Oh, this is Ahmed.
Okay, super. Go ahead.
Okay, I believe part B, the break-even price would be $480. I calculated per month, so I would be saving $40 a month. So until I get to $480 every year for the membership, then I would be actually spending more money.
Aha. So you calculated that there was a $40 a month savings. You multiplied that by 12, you got 480, and realized that if the membership costs less than 480 or up to 480, you would go for it. And if it costs more than 480, you might not, right?
Yes, that's correct.
Nice. Well, you are correct also. This is the right answer for the point of financial indifference. Super. And by the way, in a second, for those of you who are still not sure, I do have built-in explanations into the slides here. So we'll get a chance to see that. But so far, so good. I'm just kind of writing along with the solutions of our mathletes here. So nice job there. And how about part C? Part C is not a math question, right? What are some other factors which could impact your decision about joining Big Box? Anybody want to give that a shot?
Can I try?
Yeah.
Sorry, my work has been in and out twice in this play things. I'm not sure what, so I was saying something different than someone else said, but I kind of did it different than both of those things. And what I came out to, I tried to see if I was actually saving with the one, if I was actually going to save with the 150. And I found that you're not really saving with the 150. And then because I did 150 times it by 12 months. And then I did also the 40% discount, and then you multiply the actual amount you're paying, which is 3 something, I think. And then I multiplied that by 12, and then that found that was bigger. So I'm like, does it make sense to play a membership if you're not even buying that much? And then the answer is no.
Okay. So hang on. So we have a conflicting or a contradicting answer. So let's work this out and figure out how we're thinking about this, or how Liat's thinking about this, to see where's the difference. So does anybody have any thoughts on what you just heard, and maybe how maybe that there may be some kind of error or not in Liat's thinking?
I may have misheard what was said, but did she say 150 times 12?
She said she said 150
Oh,
divided by 12, I think.
Divided by
No,
12.
times
My
it
bad.
by 12 to see how many times you're paying 150.
Oh,
for a whole year.
times 12.
Yes. So
Yeah.
I think because isn't it's 150? The membership pays 150 per year, right? Not per month.
Correct. It's not.
Yeah.
So Liat, it's not a
Oh,
150.
my
It's not a
mistake.
150
Okay.
monthly. It's per
Okay.
year. It's per
Okay,
year.
there we go. That's where my mistake was. Okay, sorry.
Oh, no, but that's good. You see that's how we all learn, right? So a lot of times we get our units wrong or our periodicity wrong. That's a very common mistake. Right now, if it was, Liat, if it was 150 per month, then you would have been spot on, because you would saving $40 a month, but paying 150 for the privilege of saving $40 a month. And that would be kind of dumb. That would be mathematically stupid. So we wouldn't do that. You're right. If it was 150 a month, we would not do it. But at 150 a year, we're effectively only paying, about $13 a month. So at $13 a month, we would definitely do it. But Liat, since you're on and we're talking about this, now that you know that, what's your thoughts on part C here? This last part. Other factors that might influence besides the money, besides the math.
Is there shipping that you have to pay for? Or like what's with the taxes? Is it more higher or is it the same?
Okay, taxes could be, usually taxes are pretty standard. Shipping's a good one, but maybe I'm just old school. That's just showing my age. When I think of big box retailer, I'm thinking that you're actually physically going to the retailer. But it's a good point, right? If it was something that was internet purchased off the internet, you'd want to know if there were any shipping costs or not. But let's imagine the shipping is not a factor. Anything else?
I mean, can it be the transportation? Like when you really want to go to the store, amount of time you spend and then how much money you spend.
Good. So who's that?
Wrongling.
Yeah. So Wrongling's saying, hey, big box, if it's like 20 miles away, for example, and my normal shop is very close, Now I have to factor in the transportation costs, my time and gas money, etc. to actually get there. That should be factored. That's a good one. What else? That's one thing.
I think the sort of brands of the items that are available and like their quality.
Oh, okay. So I want to let's assume you're right, but let's assume you can get the same products. Let's assume that.
Okay.
But you're right. But stay on that. Stay on that thought, because there's more to it. Stay on that thought. What else? Think about what was stated in the exercise and what it did not state, Zach.
Maybe how much the family members are, like with a membership.
No, well, we know the membership price that was given. Let me give you guys a hint. I'm circling this food items.
Item.
This analysis was done on food items, right? Food items.
Oh, what about considering like membership costs for other big box like competitors? Like if like for example, I know like BJ's has food items, but it also has like other things too.
Right. Well, that's where I was getting at. Are there other things that the place sells that you also might purchase? Like, besides food, like BJ's and Costco sell a lot of electronics and appliances and clothing and all kinds of stuff, right? So it's not only about food. So in fact, now we already decided that it was worth it to join at 150. But even if you didn't save 10% on the food, you might still join because there might be other items that are not part of this analysis that you would go there for, right? So that sometimes our analysis is not covering the reality of the situation, right? So my sister, for example, told me, I said she goes to BJ's. I said, what food do you buy there? She said, oh, I don't go there for the food. She goes there only to buy like electronics and appliances and things like that. Okay. So that's another element. And there's anything else? These are all consideration points. Any other consideration points?
I mean, this one's probably a little weird and definitely doesn't come to people's minds most likely, but the layout of the store. Like if I'm not going to pay for a membership for a store that's like really confusing to navigate and like you get what I'm saying? Like I don't know, that might
Okay.
just be me, but
So let's quantify that. What you're basically saying, Zach, is that there's a value to you to go somewhere that is organized well, that's not necessarily in it's not in the pricing of the products. There's another value that you would place
yeah,
on
time.
on the shopping experience. Well, it could be time. It could be that
Yeah.
you just feel it's more aesthetically pleasing to go somewhere that is organized well. Could be that.
Yeah.
We can throw in here also, if one store doesn't have good COVID-19 protocol, that may be valuable to you also, right? So the point is there are other things besides savings on food items that in reality would go into your overall analysis. You can start with the price of groceries, but that's not the end of the story from a practical perspective. Okay, that was a good discussion. So let's just, again, sorry, next time I'm going to change the format and I'll just create a second slide so my scribblies don't end up on top of the the words here. I think if I actually change the slides, yeah, and then go back, they'll be gone. Perfect. So part A, yes, but already we knew that. Part B, the membership was 480, but that was also said. Part C, other factors. So here's some things that I listed in the slide. The first one wasn't stated, by the way. This analysis was done by saying that food prices on average are 10% cheaper, right? Be careful with averages, people, okay? Averages can be very misleading, right? That's why in statistics, we learn mean and standard deviation. So what I mean by that is very practically, the food you would purchase may, on average can mean that the prices compared to your normal shopping could range from I don't know, 10% more expensive to 30% cheaper, right? It could have a wide range. Maybe it averages to 10% cheaper, but in reality, that could be a wide range product by product. So you want to check the items that you normally buy, which is kind of Zach was making this point kind of in a different way. But you'd want to check the items that you buy and make sure those items are actually cheaper, right? And hopefully they're not more expensive. So I guess the moral of the story is watch out for average. Average kind of averages everything out, right? Which kind of vanillas, for lack of a better word. It kind of washes out the differences, let's say. Okay. B, we said this, big boxes sell other things besides groceries. And then C, we didn't mention this one. Going to these big box stores often encourages you to buy more volume. And before you know it, you're actually spending more money. And then in the end, happens to me here in my apartment, end up throwing out things things that are perishable. You don't get to it. All of a sudden, you find yourself like buying bigger blocks of cheese. And before you know it, you can't eat it all and throwing like 20, 30% of it in the garbage, right? So you got to watch out for that also and not fall into that trap. Nice. I like that. Let's move on to the next challenge.
Can I ask something?
Oh yeah, sure. Go ahead.
If we were going to put in like gas as a factor here, how would we like be able to factor that in, like to and from? Like, was gas is like there really isn't a real price to like how much you're going to spend on gas. So how can someone put that as a factor if it's worth?
Okay, it's a good question. It's a good question. Does anybody want to try answering that? How about someone else answer that?
Would we possibly find the average miles per gallon for that car or no?
You could. That's one thing, right? So
does that depend? But it depends on the vehicle, but also you don't really know. Let's say because let's say you're leasing it or you're renting it, or you're not really sure like what car you're gonna end up using.
Well, yeah. Okay. Good point. Let me not answer. Who wants to jump in and kind of like talk that through? Maybe one of our math mentors want to jump in. What do you guys think? How can we practically work that in reality?
I have a potential idea on how to do that, but I'm very possibly wrong.
That's okay. Let's see what you have to say.
All right. So first off, you're going to want to figure out like the miles per gallon that your car has, which, if you know the make and model, you could like you get that online. And then you're going to want to like figure out like how much you pay per gallon in gas, probably from, whatever gas station you usually fill up at, and then figure out how far away, the big box retailer is compared to where compared to the alternatives. And then you would do, let me think. You'd figure out.
This is good so far. This is good. Keep going.
Yeah.
By the way, let me just interject for 1 second. Sometimes, remember, guys, there's science and then there's the sort of practical real world. Okay. I like math and I can do math very precisely when I need to. But in the reality, in sort of like the quote unquote real world, we don't always want to treat things like a science experiment. So what that means is you don't have to, let's say, have things down to the third decimal point, if you know what I mean. Just keep things practical. You're on the right track, Zach. You're looking at, keep going, but don't worry about the minutia of the details. Just get the thoughts out.
Yeah. So if I were to like give like an example with super easy numbers, let's say your car got 10 miles to the gallon and you spend $1 per gallon on gas, which would be awesome, but whatever, let's just say. And let's say that the big box retailer is 10 miles away from your house. That means that essentially every trip to the big box retailer and back, you'd be spending around $2 in gas, because it's 10 miles to the gallon, gallons $1, blah, 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 so on and so forth. So you'd be spending $2 in gas there. But if the alternative is 5 miles away, you'd be spending, it's 5 miles there. It's what did I say? 5 miles away? Yeah. you'd be spending $1 on gas each trip because it's 50 cents there, 50 cents back.
Okay, so
if
what,
you get
just summing it up, get big picture, Zach. You're on the right track. Big picture. Don't worry about the details of the numbers. The point is, and that was Liat asking the question, I think. The point is that, and you're right, by the way, and it's not about, you do have to personalize it, first of all. So, for example, if you don't own a car and you're driving Uber or Lyft, you want to focus on the cost of an Uber or a Lyft or a taxi to get there, right? And what that means vis-a-vis where you would normally go. So, if where you normally go is a mile away, but this place is 10 miles away, we can all calculate the cost, estimate the cost of an Uber or a Lyft for a 10-mile ride. We can estimate it, right? And if not, if you have a car, whether you lease it or own it, we're not going to get into the minutia of things like depreciation, etc. Let's keep it simple. The bottom line is, what are you consuming? Gas. Gas is the main expense consumption, right? So as Zach was pointing out, we can easily calculate an estimate of how much gas we're going to use. And Zach was doing it right. So you may find out that it costs you $5 in gas to go to the big box store and only $1 to go to where you normally go. It's $4 more on every trip. And then what's the other thing you're consuming? The big thing is your time. Now, obviously, this is the big X factor. We all value our time differently. And that's just a reality, right? People value their time. People who have, let's say, usually people who, no, let me not even go there. We all value our time differently. That's a personal choice, right? You may value your time and quantify it as $20 an hour. You may quantify your time as like $2,000 an hour. Whatever it is, you value your free time. And that's another element here. And it's a very personal thing, right? So if you value your time a lot and you're very busy, then you're probably not going to want to be traveling to the big box store because it's probably going to cost you that extra, 45 minutes in the car. You value personally to be X, whatever it is. Someone else, on the other hand, who may have be unemployed or underemployed, or just happens to have free time because they're not working in a traditional job, they may value their time differently, right? And saving the money is more valuable than the time that it takes to get there and back. Okay, so it's a matter of understanding the situation. And the bottom line is, you can quantify and estimate those cost elements. Okay, does that make sense, Liat? Gas consumption and time consumption.
Yeah, thank you. I feel like, I understand it's very hard. It's gas fluctuates, Ubers fluctuates. That's what I just find complicated, but I guess there's no real answer because everything fluctuates. That's why I don't know. Like if I was in this situation, let's say I want to pay a Costco membership or something, and something like this is in reality, I'm like, okay, what am I going to do? Is it spending more or is it less? I'm like, I don't really know. Maybe just quality, I guess Costco, I don't know. But at the end of the day, I don't know if I'm saving or not, because then there's traveling and there's everything else. So it's that I feel like is the most hardest thing when it comes to shopping in general.
Fair enough. Those are all good points. And by the way, use the word fluctuate. These things do fluctuate, right? But in reality, and if you were to do these exercises more scientifically, you might bring statistics into it. But we're not going to go there with what we're doing here today. But you would start talking about normal distributions, standard deviations, and things like that. Okay. But in reality, let's be honest, unless we're talking about something abnormal, like abnormal surge pricing, we pretty much know more or less what the cost of an Uber or Lyft ride is. We can kind of come up with an expected value, right? That's probably not far off from reality. And gas doesn't fluctuate as much as you think, right? Gas prices are pretty stable. Maybe in Brazil, they're not stable. But in here, in the United States, they've been pretty stable. So, if we assign gas to, $2.80 a gallon, it's been pretty much plus or minus 280, for a while now, but you're right. It's not perfect. It's not perfect. So that's why so none of this is perfect. None of this is perfect. It's not the way we're going about this is not a perfect science, but in reality, you could still make certain assumptions and get very far with that. Okay. All right. Nice discussion. Let's move on now to challenge 3. So challenge 3, this is fun. I don't know where I came up with this exercise. I just, maybe I was thinking about the movie The Wedding Planner. So you're getting married. You want to hire a wedding planner. You've narrowed it down to 3 choices, each of whom have, they're all great. So you don't have to worry about quality. Their pricing schemes are very different though. And you want to understand them better, or the pricing schemes. So here are 3 wedding planners and the way they price themselves. The first one charges a fixed fee and then a fee per invited guest. The second one charges no fixed fee, but a higher fee per invited guest. And the third one, to make life more complicated, does it completely differently. They charge a flat fee based on like guests at a certain way. So if it's under 20 guests invited, they charge one number. If it's 20 to 99 guests, they charge another number. And if it's more than 100 guests or more, they charge a third number. Okay. Wow. A lot to think about. But in reality, these are the kind of decision points that we have to make in our lives. So part A, which planner offers the best price for 75 guests? And how about 150 guests, right? So we'll get back to that in a second. Part B is there some number of guests where you would be financially indifferent? That means they charge the same price between the 3 planners, some number of guests, okay? And can you graph it? Can you graph the 3 pricing models and show that point of intersection if one exists? Can you show it? And this is an awesome exercise because this type of data visualization is important in just so many different areas of business, okay? So I'm looking forward to hearing what you guys have to say. Does anybody want to volunteer to try part A or kind of talk it through?
I can try it.
Who's this?
Wrong link.
Wrong Ling. Okay, awesome. So go ahead. Do you want to?
Yeah, I did a graph for the part A. I can put it in the chat.
Yeah. Are you able to draw on the screen at all? Wrong link? No?
No,
all right.
I can't.
Would you like me to write for you?
Yeah.
All right, I'll write for you. Go ahead.
So for the plan A, for plan 1, I write down the equation y equals to 50x plus 1,500.
Great.
And then for the plan 2, y equals to 80x.
Great.
And for the 3, I put 2,500 less than x. Less or equal to x.
Okay.
And then
that's not going to work though, right? What is x? X is the variable x stands for what?
For number of people.
Right, number of guests. So that's not going to work. I know what you're trying to do here, but setting it up like this, right? X is this is 2,500 is dollars. So the third one doesn't. Let me give you a hint, Wrongling. The third one doesn't have a classic like linear equation. You're not going to be able to express it that way.
Yeah.
Right. So let me help you here because the third one is you can't write an equation. You did it perfectly right. The first 2 are perfectly right. And hopefully the rest of you all see that. The third one, we can write this as this is a function where the value is 2,500, for when x is, maybe we can put a colon, when x is, and this is what you meant to say, less than or less than 20, 4,000, and then we'll put a semicolon, when X is between 20, less than or equal to 20, greater than or equal to 20, less than 100, and 7,500 when X is greater than or equal to 100. Okay, is that what you meant? That's what you meant, right, Wrongling? Wrongling?
Yeah.
That's
Oh,
what you meant. All
yeah.
right. So you want to continue?
Yeah, and then you plug in the equation for the X. We can calculate the 75 first.
So what do you get for the first planner at 75? So
I got 5,250.
okay, so at 75 guests, planner 1 is that price. Planner 2 is how much?
6,000.
Okay. And planner 3?
And 3 will be 4,000.
All right. Those all look correct, those answers. So you see what Wrongling did? She created functions from the information provided, and then she, with a variable X, she plugged in then X's number of guests, and then she basically used X equals 75 and used these functions and got these dollar values. So in this case, Y, or the outcome, is basically the dollars, right? And now, so clearly the cheapest one is the third one. Now, Rongling, how about 150 guests?
Hold on wait a second. I got for the plan 1 for 150 people will be 9,000.
Okay.
And then for plan 2 will be 12,000.
Okay.
And then for plan 3 will be 7,500.
Okay, that all sounds correct. And again, the cheapest, most economical is wedding planner 3.
3, yeah. It stayed the same for the.
Exactly. And that, by the way, that was, if I was doing this exercise again for you, I would change number of guests. The first one probably use a different number. It just worked out that both at 75 guests and at 150 guests, that wedding planner 3 had the best pricing. Now, let's stay with you, Rongling. Did you get a chance to do the part B?
Yeah, I did, but let me see the graph I did. The intersection point is 50 people for $4,000.
Yes.
You have the same amount of money spending.
Yes. Beautiful. For 50, when you have 50, when X equals 50 or 50 guests, and you use 50, you plug in 50 to these 3 different wedding planner functions, you're exactly right. You get $4,000. $4,000. Did anybody else? Thank you so much, Rongling. That was super. Did anybody else get the same answer? Anybody want to? I'm just curious if anybody else got there. Anybody else?
Yes, I got the same answers.
Who's that? Sorry?
This is Ahmed.
Ahmed.
Yes.
Awesome. Awesome. So anybody else or anybody besides Ahmed and Rongling?
I got the same answer.
Awesome. Awesome. Okay. Let me share because it's hard for you guys to draw a graph on the slide. So let me share with you a graph that is already pre-done. Okay. Let me actually move off this slide, come back so I can get rid of the scribbles. So let me just show you typed out. This Rongling answered this beautifully. Okay. But let me, just to make it clearer, because rather than looking at my scribbles, here again are the 3 functions. Now, Rongling used Y equals 50x plus 150, 1,500, for example, or y equals 80x. And you see here, I used f of x. It doesn't really matter, actually. You can show your functions. You can use a y variable and then as your dependent variable, or you can write it as a function like I did here. Either way, it's the same thing, okay? And here's what the graph would be. So you see my vertical axis, instead of y, I have f of x. Again, it doesn't matter. So here's the representation of the first wedding planner. And the way you do this is you would try to like plot, you can take any two values for a number of guests or a variable x in this case. Clearly, so when there are no guests, for example, we know there's a fixed fee of 1,500, and at 100 guests, we can calculate 6,500. That gives us 2 points, and then we can draw the straight line for the function value. Okay, so that's what we get for a first wedding planner. Second wedding planner has no fixed fee, right? The function was simply f of x equals 80x. So when x is 0, f of x is 0. That's why it starts at the origin, 0, 0. And then also for 100 guests, that you get 8,000, right? 80 times 100 is 8,000. And then finally, the third function is a little bit funky. It's not a straight line. It's more of a stepwise, and it would look like this, right? Under 20 guests, it's a fixed price, 2,500. The open circle, by the way, means that it doesn't include the endpoint, and the closed circle means it includes the endpoint, right? So at $4,000, it's $4,000 from 20 up to just under 100, so 99 guests. And then at 100, it starts $7,500, and it's flat, right, all the way across. So if you have like 200 guests, 300 guests, 400 guests, the third wedding planner is charging flat rate. Okay, so this is really, really, really powerful to be able to show information graphically like this. And I want to point out to you that the area under the curve, all the areas below the lowest point of these three graphs. So this area that I've just kind of colored in here, this helps you understand visually at different guest amounts where you would choose different wedding planners. So you would choose the first wedding planner up to here. You would choose the first wedding planner. Then you would choose the the third wedding planner here. Then you would choose the second wedding planner just in this little bit here. And then again, the third wedding planner is cheaper after whatever this point ends up being. It looks like about 110 or so, okay? So the final part, though, to point out is that these three graphs do intersect right here, as Rongling pointed out. They meet at 50, right, where x equals 50, which equaled the 50 guests. And as she said correctly, that's $4,000, okay? So hopefully that was interesting and valuable for you. In many classes at Brooklyn College, you'll find yourself having to make graphs and visualizing your data this way. And frankly, in the business world, in many different jobs, you're going to have to give a presentation, and sometimes you might have to actually create graphs like this as well. All right. Does that make sense? Anybody have a question on that, or want to share anything they want to comment or question? Anything at all? Okay. All right, good. Let's move on then. And to challenge 4. So challenge 4, we're shifting gears a little bit. to a situation where you're buying and selling some shares of a company and you want to calculate your return on investment and your annualized rate of return. Okay, so in this exercise, you invested $1,000 on January 1st, 2019 to buy 50 shares of some fake company, XYZ company. And by January 1st, 2021, the share price jumped to $35. You decide to sell the shares at that price. So disregarding any fees or commissions, part A is what is your percent return investment? And part B is what is your annualized rate of return? Who wants to jump in and try part A?
I could try part A.
Okay, Zach, go ahead.
Okay, so if you invested $1,000 to buy 50 shares, that means it's $20 per share.
Right.
When the share price jumps to $35, that means your $1,000 becomes $1,750,
Okay.
and that would mean that your percent return is 175%.
So you went from 1,000 to 1,750, and you're saying that your return is 175%. So very close and almost correct, but there's one small mistake.
Yeah, I think I see it, because wouldn't 175% would be like, that would mean that I think I understand in my head what I did wrong. Would it just be 75%?
It would be 75%. Now let's see if you can come to the end. Let's see if you can come to why it's 75% and not 175%.
Well, the reason it's 75% is because 100% of your investment is 1,000, and
Right.
gained $750, which is 75% of 1,000.
There you go. Exactly. 100% is your original number in the way you're looking at it. Because like Zach, if I said you sold it for 1,000, like if you went from 1,000 and you sold it at 1,000, what's your gain?
0%.
Right. Not 100, 0.
Yeah, exactly. Yeah, my bad.
Right. No, so you're right. Everything was right, except at the end, you have to subtract out. If you do it this way with the total dollar amounts, you have to subtract out the 100 off of this. Well, your math here, I guess, was 1,750 over 1,000, right? And
Yeah.
you get 1.75. The key is you have to subtract out 1. And that tells you your gain is 75%. So your return investment, and by the way, I believe I have this formula here for you guys. So, which is basically exactly what you said, Zach, except you didn't net out the amount spent from the equation. See, if you think of it like if you look at this model, what you're really doing is you're subtracting 1,000 from 1,750, right? So you're actually first can calculate the amount you actually gained, which is 750. And then you put the 750 over the amount spent, the original number, which is in this case 1,000. And then you wouldn't have to subtract 1.
Mm-hmm.
Does that make sense?
Yeah.
Does that make sense? All right. Okay. Thank you. How about the annualized rate of return? Does anybody want to try part B? Someone else, maybe? Who has an answer for part B? What's the annualized? How can we calculate the annualized rate of return? Any finance majors out there? Nobody?
I have an answer.
Okay. Just say your name just say your name again, please.
This is Mila. Sorry.
Mila, that's okay.
So I used a formula for
Okay.
annualized performance rate.
Okay.
I took 1,000 plus the 750.
I'm just writing down
Okay.
what you say. 1,000 plus 750.
Mhm.
Okay.
Divided by the initial 1,000,
Okay.
which is our principal.
Okay.
And I raised all of that to the exponent 1/2 because 2 represents the number of years.
Yes. Great. 2 equals, well, we'll just call it 2 is the number of years. Oh God, these scribbles are terrible. But you're right. 1 over the number of years is 2 years. Yep.
So that comes to 1.75 to 1/2. So 1.3229, and I subtracted 1 to give us 0.3229 multiplied by 100%, giving us
Yes.
32.29%.
Excellent. That is exactly right.
Yeah,
Exactly right. Well done. Well done. So, and by the way, folks, if you ever like, so you found the right formula to use, but I don't like, you need formulas, but I want people to understand why the math works out the way it does. Zach calculated that the overall return on investment is 75%, and that was correct. It was 75% over 2 years, right? 75% over 2 years. Now, if there was no such thing as compounding, then if the annualized return, you might say, well, can't we just take 75 and divide it by 2? And you'd get 37.5. And like, yeah, okay, so that might be a decent answer. But there's the effect of compounding, right? So usually when we talk annualized rate of return, we assume that there's a compounding going on. And we would use the formula, which I'll show you in a second here. It's written clearly on the slide. You use a formula which accounts for the compounding, right? And obviously, because of the compounding, your annual return is going to be a little bit lower than just the sort of the straight division of dividing 75 by 2, because with compounding, like, things build on each other, right? So you would expect to see an answer that's a little bit less than half of the straight division of 75 divided by 2, right? Again, 75 divided by 2 is 37.5, and an answer of 32.29. Just to gut check it, it makes sense. It makes sense. Now, let me just kind of take you through the slides. So here's the formula, the 2 formulas you need here. And these are good formulas to write down. Of course, they'll be in the slides. You can always go back and watch the video, but you might as well have them written down in your own notes. And how they're applied, I think I have here, yes. So here's how they're applied. I'm not going to take you through all the points here because we just went through the same exact thing as what you see here. So yeah, just plug and chug. Once you know the formulas, you're good to go. But you should, again, know why the numbers end up being the way they are. Okay. So I just rounded my answer here to 32.3, but that was where we got to a moment ago. So very well done, Mila. That was Mila, right? I think that was Mila. Great job. Let's move on, because we still have two things to talk about. We only have 11 minutes before it's technically the end of our meeting. Lots to do. So challenge number 5. This is getting into credit, right? Credit's a very important topic. Lending, micro lending, all this kind of stuff. We all need to get smarter when it comes to like looking at credit options. So in this particular exercise or challenge, you're interested in borrowing $100 to make a purchase on credit and have two options. You have a credit card that offers you an annual interest rate of 24% compounded monthly. And option two is a short-term lender who says they can lend you the money at just 5% of interest per week. That's all, just 5% interest per week, okay? And that's all you know. That's what you've been proposed. You've got the credit card, 24% annual interest compounded monthly, or this short-term lender who says they can lend you the $100 at just 5% of interest each week, right? Now, assuming that you're not going to pay anything down, this is going to sit for a year, okay? You want to pay this back a year from now. So you want to be able to estimate what you're going to owe at the end of 1 year. So how much would you owe after 1 year in these two cases? And then kind of like part B, is there anything potentially misleading in the option 2 offer? So who wants to jump in and help us solve this? Any volunteers? We've heard from Rongling, we've heard from Mila, we've heard from Zach, we've heard from Brittany, we've heard from Ahmed, Rongling.
I mean, I did the number 5, but yeah.
Is this Rongling?
Yeah.
Okay, go for it.
I did the number 5. I use a function for the I don't know how to call. I forgot the function name. I use the function is PVFE I think it's the function from last semester.
Right.
The the future value equals to present value.
Right.
And then 1 plus r
times
1 plus r raised to the r power.
T power.
Oh, sorry.
T.
Yeah.
Yeah. This is good. This is what you just told. This is correct, Rongling, and you're right. We did do this last semester in the MathMinds. Future value equals the present value times 1 plus the interest rate R raised to the number of time periods, right? But what's the important here is that your T and your R are in the same periodicity, meaning if you have years, the interest is in years. If you have months, the rate must be in months. So this is the compound formula, by the way. This is a compounded interest. So you're right. So now how can we apply this formula in option 1?
You just plug in the numbers they given.
But what numbers do we plug in?
For PV, the present value is 100. Yeah.
100.
Yeah, you have borrowed 100, and then you have multiplied by 1 plus 0.24.
0.2 point what?
24.
Now here's where, all right, but let's continue for a second. And what's it raised to?
12.
All right. So here's where there's a slight error, because and this is a typical error that is made in these exercises. You must match the time periodicity of the compounding to the interest rate. So since the interest rate was given
0.0
annual, you have to change this 0.24, which is annual, to monthly. So what do you think the monthly
will be? 2%, 0.02.
Right. So I'm just going to write over this 0.02. Right. Okay. And can you tell me what that equals?
Wait, hold on. Let me do the calculation. Uh, Very quick.
Okay. Anybody want, someone can put it in the chat box if they know. Anybody know? Want to add to the chat box what the future value is for option 1? And Ilya has a question in the chat box. Is anybody able to explain how they arrived at the monthly interest rate? And Brittany, that's correct. 126.82. Sorry, Rungling, but we just for the sake of time, since Brittany already had it calculated, well, that is correct. All right. So that was, so Rungling, thank you. Now, Brittany, since you jumped in, do you want to jump in for option 2? How would you think about option 2? How might you think about option 2?
Okay, just thinking. Maybe we're still writing the same 100 plus open bracket to 1, no?
Well, this is just it. In practicality, you might be faced with someone who wants to give you a deal and just says this, right? And I must admit, this is purposely written a bit ambiguous. Okay, this is purposely written a bit ambiguous. And that's exactly what we're trying to train you guys to see. Okay, so how do we analyze this $100 lending offer at 5% of interest each week?
Wait, isn't it like 1 year having not like sometimes have 365 days and sometimes 366 days? How do you know?
Well, I wouldn't worry about that detail. I mean, the fact that there's a leap year, don't worry about that. Let's just assume it has 365 days. But anyway, in this case, it's not daily. It's 5%. It says that they'll lend you the money at just 5% of interest each week. What can that mean?
Like every week there's an additional of 5%. Like it adds 5% every week.
Could
So
be, right? Now, what is 5% of 100? The amount that you're trying to borrow? $5. It could be that you're paying $5 every week. Now let's go with that as hypothesis that you're paying $5 in interest every week. How much would you have? How much are you paying by the end of the year just in those $5?
260.
Right. And now if you include the original 100, how much do you have that you owe? 360. 360. All right. Do you see that difference right there? Yeah. So this is here to demonstrate to you how even though this 24 is a much bigger number than 5, you have to be very careful the way information is presented to you, especially when we're talking about lending, right? Because a lot of times a short-term lender will do exactly this. They give you some amount of interest, like a fixed interest, and that, in this case, they tack it on every week because their model is not to have you borrowing for a year, by the way. Usually a short-term lender would expect you to pay something back quickly, right? But check this out. let me change the exercise. Now, it's a very fair hypothesis to think that it's tax on 5% each week. But actually, by tacking on just 5% each week, this is actually a simple interest methodology, not compounded interest, not compounded interest. So here, let's imagine, it's not in the exercise, but let's imagine this 5% interest is compounded weekly. In other words, it's 5% each week compounded. So we're using this formula that we used for option 1, but we're putting in here, instead of 2%, we're putting in 5%. And instead of raising it to the 12th power, we're going to raise it to the 52nd power. 52nd power. So can someone calculate 100 times 1.05 raised to the 52nd power?
I think the answer will be 1,264.
That
28.
sounds about right. That sounds about right. I have the answer on the next slide. That sounds about right. But think about that. More than $1,000. Okay. So let's just look at what the answers look like, right? So here's the simple interest model, right? This is without compounding, and this is only here as a review, okay? So if you guys haven't learned finance, it's totally understandable that this is new for you. That's okay. You know, you can learn some now, and then if you take a finance class, you're gonna be better for it, okay? Compound interest formula is a little bit different, right? We have this compounded element of this T, which, raising this T power mathematically compounds this 1 plus R, whereas in the simple model, the T is just multiplied by the interest rate, okay? So here are the two formulas you need to know, and let's just apply them. So we said option 1 is 126.82. That was correct. Option 2, simple, 360, which is correct. And Wrong Ling was right. If you compound by 5% each week, you would owe $1,264.28. Look at the difference between 360 and 1,264 and change. Look at that. That is the impact of compounding at its best. Look at that deviation. So the moral of the story here is that option 2 is misleading. It doesn't explain what actually is going on. And if you were actually faced with such an option, you would have to do more digging. You would want to understand exactly what the deal is, how the interest is compounded, and what it means to say 5% of interest each week, okay? Because too many people would confuse that with 5% interest over the year, and they would mistakenly go for option 2 over option 1, okay? So that is a lesson to be learned right there. Woo! All right. So that was a mouthful. We are now done with the math for today, but there's one last challenge. The last challenge of the day or the week was to, while you're out and about, report back on a shopping situation where good math skills would come in handy, right? And to share with the group today. So did anybody who would like to share something that they thought about, or if you took a picture, let me know and I'll let you share your screen if you want to show us something, or if you just want to talk about it, that's fine too. Who wants to jump in first? And if the math mentors want to jump in here, that's cool too.
I got one.
Okay, Zach.
Yes. So whenever Rena and I order groceries, we use Instacart, and Instacart stopped using the setting that allowed you to sort by unit price. So we've started having to try and calculate the unit price. Very rudimentary. We don't like use like any sort of like we don't like overthink it, but
Right.
we definitely like use those math skills when we do that.
Uh-huh. So you mean just doing your basic division to get the per product per unit price. Got it.
Yeah, yeah, for sure.
Okay.
Nothing too complicated, but yeah.
That's okay. That's fine. Good. That's a good one. Thank you, Zach. Anybody want to, anybody have any other things to share? Any other thoughts, examples?
For me personally, I would say probably trading stocks and investing, because it's very important to be able to calculate the ROI potentially, and how much money you could make, or potentially the money that you could lose.
Oh yeah, well for sure. If you're trading stocks, you better have some seriously good math skills, no doubt about it. So that's yeah, absolutely. But I'm even going simpler than that. But that's a very good point, of course. You know, I'm just talking about like when you're out and about shopping. So Joshiba, go ahead. You can unmute yourself.
Yeah, it was something simple too. Just knowing how much of an item I can get with a certain amount of money. Or
Right.
just like, yeah, or another one was like if something is like 2 ounces and it's like $3, if I get something doubled, like something along those lines, like if I'm paying much more getting a bigger one, or just getting 2 of the same size, smaller one.
Right. Perfect. Perfect. I recently was in the shop and buying some baby formula. Baby formula, right? We have a newborn here, and like just as a backup. So I went to the baby shop, I'm looking at baby formula, and there were 3 sizes. There was like a small, medium, and a large. And I had to kind of figure out the prices, you know, baby formula is not cheap. So I had to kind of figure out, well, what's like the per ounce price? And I literally did the math, like to see how much of a savings I would get on buying more volume. So that's to Joshiba's point. It's exactly that kind of situation. Good. Anybody else have anything they want to share that they ran into? We want to talk about?
Hey,
Hey.
yeah, so I actually haven't really, we've been kind of minimizing our outings, like our grocery outings.
Right.
But one thing that did come up was actually when I went out to have a beer at a bar, and they have like, you know, the stout beers.
Uh-huh.
It has a higher ABV, like alcohol by volume, but they give you a shorter pour, and they're usually around the same price. So I did actually have to quickly do that math in my head.
Yeah, that's a good one.
Yeah.
Alcohol concentration.
Exactly. Yeah, you gotta sometimes you gotta, especially like in college when you have to like calculate the bang for your buck and stuff. You gotta think about these things.
That's true. If you want to get the most like alcohol consumption per dollar spent, you got to look at the percent alcohol content multiplied by the ounces. That's a good point. That's a good one.
There you
Not
go.
not that we're condoning any drinking for anybody on the call who might not be 21. By the way, of course, we don't want to do.
No, we would never.
Okay, that's a good one. Thank you, Illy. Anybody else want to share? I got a few pictures. I quickly snapped a few pictures I'll share with you. Real simple stuff, right? I was walking in my neighborhood. So here you go, right? 1. So now you go into the restaurant. So all the restaurants have these signs, right? 35%, 30 customer capacity. Now, frankly, that's a little I don't really frankly don't understand that communication, because I can't tell if that means that 30% is 35% of their capacity, or 30 customers is 35% of their capacity, or that 30%, 30 customers is their capacity and they can take 35% of those 30 customers. Little unclear. I assume what they meant was that they can take 30 customers in the restaurant, and that equals 35% of their capacity. But if you wanted to quickly calculate what their capacity was, just because you'd want to know or make sure that, like, you know, that actually you were reading it correctly, you want those math skills to be able to do that, right? Here's another one. I passed this bank. Simply free checking, right? You always love that free in marketing, right? You always love that because free, nothing's really free, right? We know nothing's really free. So you want to have, you want to open up a checking account in this bank or any bank or, whatever the case may be. You want to kind of understand the numbers behind the free, right? Are there minimum requirements? Do they give you any interest or not? Probably not these days, right? Are there big fees for things like, a bounce check or this kind of stuff, right? What else comes with it, right? So you want to understand what free means and understand what the numbers are behind opening up a bank account. And then finally, simple, real simple, and I'm a big pizza lover, and I imagine some of you are as well, but you've seen these deals, right? 2 slices and a soda, $5.50, right? So like if you want to be able to figure out like what's the deal actually? How much of a deal is that? You want to be able to, look at what their prices are normally for per slice and how much a soda costs and figure out like, are you really saving anything really useful there or valuable, right? So being able to quickly do the math comes in handy. And these are just 3 very simple examples that I ran into walking down Smith Street in Brooklyn this past couple of days. All right. Anybody else? So anybody have anything else they want to share that bring anything to mind? Okay. I'll guess the answer is no. Thank you for sharing for those of you who did. So the moral of the story is, folks, shop smartly. Use those math skills when you do your shopping. And as you can see today, it can be applied in many different ways. Next week, our next math mission is called Deal or No Deal, right? Those of you know that game show, which is something I find myself binge watching at times. Deal or no deal. So we're going to continue with the finance track, and we're going to talk more about business corporate finance applications. So that math mission will go out probably tomorrow evening to your inbox, okay? Probably from Michelle. So look out for the Deal or No Deal math mission, and we'll talk about that next Tuesday. And if there's no other questions or I'll be happy to stick around for any last minute questions, but look, it was a great meeting today. Thank you for joining. And looking forward to seeing y'all next week. Any questions though? I'll stop for questions or comments.
I have like a question.
Go
Like,
ahead.
do you like teach like other classes, or like is it only maths you focus on?
Well, no, actually, I mean, I've taught a variety of different, personally, let me just stop the recording here and I'll answer that question. So thank you all for watching the recording and for being here today. See you next Tuesday.